All right, example 6, use Newton's method to find the critical numbers of that and find the absolute minimum of the function. Now look at the difference in this question and the previous ones. The previous ones were asking us for the roots of the function, right? This is asking for the critical numbers of the function. Critical numbers and the absolute minimum. So they're talking about the first derivative of critical numbers. All right? First derivative of critical numbers happen at endpoints, which there aren't any. They happen at undefined, which is polynomial, so there aren't any. So where the derivative equals 0 is what we're looking for. So here's an application of Newton's method here. If this is my function, then f prime of x is going to equal 4x cubed minus 2x, or sorry, minus 6x squared, minus 6x plus 5. All right? I want to know when that thing equals 0. So this time what I'm solving is the derivative. So what I'm going to do is I'm going to let y sub 1 be this function that I'm trying to solve. And y sub 2 is supposed to be its derivative, which is going to be 12x squared minus 12x minus 6. Okay. So if you're actually using Newton's method as a tool in helping you find critical numbers, and part of the job of finding critical numbers is set the derivative equal to 0, Newton's method is a technique for solving a function equal to 0. Let this be the function, let its derivative be y sub 2, and that allows us to use Newton's method to find the answers to this function, not that one. We all see that okay? All right. Also, they're asking us to find the absolute minimum. I don't have to do increase and decreasing intervals here. Once I get my critical numbers, if I just substitute them into the function, whichever one gets me the smallest number is the absolute minimum, right? So once I get my critical numbers, there's going to be 1 or 3 of them. Okay, if I get 1, fine. If I get 3, fine. If I get 3, I'm just going to substitute all 3 numbers in. Whichever one gets me the smallest amount is going to be the absolute minimum. If they ask me for all the extreme values, the minimums and maximums, I want to do some increase and decreasing intervals, that kind of stuff. But in this case, just substituting the numbers be sufficient. So I'm going to type in y equals, I'm going to clear out what's already in there. y1 is going to be 4x cubed minus 6x squared minus 6x plus 5. And y2 is going to be 12x squared minus 12x minus 6.
12 squared.
Did I? Thank you, David. 12x squared minus 12x minus, excellent. Okay, and I'm going to turn off function 2 because again I'm looking for where the derivative equals 0. There's the derivative. So I'm going to do a zoom 6 again. Standard viewing window, negative 10 to 10 in all directions. Looking for places where it crosses the x-axis. Looks like negative 1, maybe about 0.8, maybe around 2. If I want to get a better view of that, I can just zoom in. Let's go from negative 2 to 3. Get graph one more time. A little bit left of negative 1. About 0.7. Pretty close to 2. All right. So if I go with those guesses, so x1, I'm just going to guess negative 1. x1 is going to be maybe 0.7, and x1 maybe is going to be 2. And the only thing that would be bad about these guesses, if they make the derivative equal 0, doesn't look like any of those numbers will do that, though, so we should be good to go. So, go to Newton's method. Again, I just hit enter, it's already there. Negative 1 is my guess, and they want, it doesn't specify, let's go 6 decimal places. So, the x value I get on this for critical number is negative 1.052741. Enter. My next guess is 0.7, 0.611731. My final guess is positive 2, and we get 1.941010. Okay, so there's my 3 critical numbers. So again, if they didn't ask for the absolute minimum, if they just asked for the minimum, or the extreme values. I want to go from negative infinity to the first one, the first to the second, second to the third, third to infinity. Increase, decrease, find max and min, like we did in chapter 4.6, right? They're asking me for the absolute minimum. okay? The absolute minimum happens at one of these three values, and the absolute minimum is the smallest value, right, for the entire function. So what, just to give you an idea, a fourth power function with three critical numbers is going to do this. It's going to come down, up, down, up. All right, so that's what it's going to look like. Or it could look like this. That's the same picture, isn't it? It could look like this, where it goes down further here. Or they could go down to the equal amounts. I mean, those are the possibilities. But when there's three critical numbers in a fourth power function, there's going to be three bends. All right? So, if I go y equals, now I'm going to clear out, because I've already found everything I need to with this stuff, right? What I want to do is evaluate the function itself at these three numbers to establish which one gets me the smallest value. So actual points on the graph. This is the graph we're trying to graph, right? So if I substitute these three critical number values into the f of x function, that gives me the overall outcome values of these things here. So I'm going to clear out these, oops, maybe I'm going to clear them out. All right, so x to the fourth minus 2x cubed minus 3x squared plus 5x minus 9. And I'm just going to go to my table and enter these three numbers. Negative 1.05, 2741, 0.611, 731. This one here should be the maximum. And the two on the end should be the same. Minimum, maximum, minimum. That's what I'm expecting, right? 1.94, 1010. So of the three values we get, negative 14.03 is the smallest of the three, right? So I can go up here, and again, let's suppose they said 6 decimal places. I can go up here to the y column, get as many decimal places as I need there. So this is the absolute minimum. And I'm fine just in ordered pair for this. So x is negative 1.052741, comma, y is negative 14.026819. And again, this will be a task in your homework tonight where they're solving just regular functions. They're also going to be applying it to stuff we've already been doing with absolute, minimum, maximum, critical numbers, that kind of thing. So again, what you have to ask yourself every time you use Newton's method is a simple question: what do I want to equal 0? That's what y1 is. Its derivative is going to be y2, and that'll get you the answers you're looking for. But again, it's up to you to relate the question to some stuff you've done in the past to know where you go in each case to find what you're looking for. A lot of functions on your paper, each time one of those functions will be more important than the rest as far as what you're trying to do with it.